Hi, calculus students. This is Ms. Orloff. I want to do a quick review of IVT, EVT, and MVT. I have sent this document to your OneNote, and I'd like to review it before I do an AP problem that incorporates these three theorems. So IVT, Intermediate Value Theorem. Remember, the name really gives away what it's saying, intermediate, in the middle. So criteria that must be met. First, f has to be continuous on a closed interval. And then the main key to this is that if f is continuous from A to B, then there is a number n between f of A and f of B, where f of A does not equal f of B. And so we're going to find essentially use intermediate value theorem to say, hey, we can find this output and we can also find that value of C. So two parts to that. The College Board can ask you, does this value, can it occur? And they can also say, well, now that we know that it can, where does it occur? So I have written a really brief question off to a side that can come up, where it says f is a continuous function on the interval -2 to 3. So the key here is it must say continuous. If not, we cannot make the assumption that the function is continuous, especially when we have a table or tabular information. And so I'm telling you it's continuous from -2 to 3, and something I can ask is, what are the least amount of zeros f of x can have and justify your answer? So I'd like you to pause the video and determine the least amount of zeros. So the least amount of zeros that function can have is 2. And it is because the intermediate value theorem, because the function is continuous on that closed interval, and then we know the outputs change from positive to negative or negative to positive at least twice, because we don't know what happens at things like -1.5 or 0.5 or things like that. We know that there's at least 2 times f of x will equal 0. EVT, the extreme value theorem. So extrema, now we're dealing with maximums and minimums. So if f is continuous, so we always have to look for these things like continuity. What is the criteria that must be met? And it must be continuous on a closed interval. Then f has both a maximum value and a minimum value on the interval. And when I say max and I say min, we're saying absolute, not just relative. And so I'm guaranteed that. This is where checking those endpoints can come into play. We should always check endpoints. They're most likely something. Now, I am not saying absolute extrema, but they're most likely local and potentially absolute. So take a moment, look at the diagram, and make sure you have a good understanding of extreme value theorem. So mean value theorem, I had you do a module in class over this. Mean, average, right? So a little bit more criteria needs to be met for the mean value theorem. F needs to be continuous on that closed interval, but also differentiable on the open. And I want to emphasize the open. There exists a point C on that, the open interval from A to B, such that the average rate of change equals the instantaneous rate of change. Now, we're never going to look at the endpoints, remember that. So geometrically, what that means is there is a time when the secant line between 2 points is parallel to the tangent line. So we have to first determine if the mean value theorem applies, and then the time will come where we have to find when. And when we're trying to find when, We're not looking at the derivative, we're looking at the function. So this is a summary of IVT, EVT, and MVT. I would make sure prior to taking that AP test you have a good understanding and you read through that criteria.